Hey, this is Mr. Aiden. This is AP Calculus AB, and we're going to be doing integration by me substitution. No. Wait. Not me. You. U substitution. I think U substitution is one of the coolest, most ingenious things ever to come up with within the realm of calculus. Even though all of calculus is so cool, this is really cool. When doing integration, we're basically performing, obviously, reverse differentiation. We're doing the antiderivative. Some integrations are really straightforward, like the integral of 2x dx. That's x squared plus c, isn't it? Other cases, it's not that simple. We have the integral of cosine of 3x plus 5 d of x. We kind of have the chain rule going on here, don't we? It's not just simple and straightforward. And so we can use U substitution, which is basically the reverse chain rule, which is just so stinking cool. Okay, so let me kind of walk you through U substitution. Like I said, U substitution is so neat here. Here we have the integral of 2x cosine of x squared dx. This is not a straightforward integration. This is not just the integral of cosine of x. It's 2x cosine of x squared. So what are we going to do? We're going to take this guy right here, and we're going to call him u. So u is equal to x squared. And then we're going to say, we're going to do the derivative of this function, which means du is equal to 2x dx, isn't it? Or du over dx equals 2x, or du is equal to 2x dx. Now we're going to substitute in my original function here, okay? And I hope you can see, I kind of called these, I kind of did these in colors to help you out. Do you see 2x dx is in purple? We have 2x dx right here. What is 2x dx equal to is du. Then we have cosine of what is your x squared. Your x squared is equal to u. Now this is a nice straightforward integration, isn't it? The integral of cosine of u with respect to u is equal to sine of u, isn't it? Because the derivative of sine of u is cosine of u. And so, now at the end of the day, we can plug in what u is, which is x squared. And that is my integral by U substitution. There's no other way I could do this. Now, think about this logically. If you were to take the derivative of sine of x squared, what would that be? It would be cosine of x squared times the chain rule times 2x, which is 2x cosine of x squared. And you can see, you can double check your answer to make sure it works out by using the chain rule. So let's do another example. We're trying to find out, first we got to figure out what we're going to use for our u value. What are we going to use for our u value? And I'm going to use this dude as my u value. U is equal to 2x cubed plus 5. Now I'm going to take the derivative of these. So the derivative of u is du. The derivative of this is 6x squared dx. What do you know? I have a 6x squared right here, dx, 6x squared dx, which is equal to, that's equal to du. This guy in the parentheses, we called that u, so we have u to the 6th power, don't we? So all of this right here is u to the 6th power, because I called u 2x cubed plus 5. Took the derivative to replace this dx with du. And so you can see how I can do this straightforward integration here. This, remember the reverse power rule, we have 1/7 u to the 7th power. Now at the end of the day, we're going to plug back in what u is. What is u? 2x cubed plus 5 to the 7th power. And that is my integration, plus c, of course, plus c. And then Totally forgot to put my plus c there, plus my constant. Okay, don't forget your plus c. Think about the derivative of this. Think about the derivative with respect to x of 1/7 2x cubed plus 5 to the 7th power plus c. We're going to do the power rule. So 7 times 1/7 is 1. So we get 2x cubed plus 5 down to the 6th power times the derivative of 2x cubed plus 5, which is 6x squared, and I'm left with what I had at the beginning. It all worked out, and I checked it, yo. Let's take a look at another one. This one's a little bit more difficult because you can see in this one right here, I see x squared, I see 2x. I know I'm going to use my u as x squared. I see 2x cubed plus 5. I see 6x squared. Do you see the derivative right there? So whatever is the higher power is usually going to be your u. Okay, so whatever the higher power is will be your u. Now, you are not the higher power. God's the higher power. But no, I'm in a calculus problem. The higher power is usually going to be your u because when we do the power rule, that is the derivative, and that can get rid of that x. So with this one, it's not as readily seen of what we can use as u. Now, I'm going to use this right here as u. U equals 2x plus 7. Now, why would I do that? Is the derivative of my u here of 2x plus 7 is 2dx. 2dx. Now, if you can see, in every single one of these problems, I kind of did my little u thing off to the side. I did my little u thing off to the side. I do it the same way every single time. Now, you can see there's no 2dx here, is there? There's just a dx. So when I solve for dx, I have 1/2 du. 1/2 du. Now I can substitute. The integral of this is considered u. This is considered u to the 3rd power. And what is dx equal to? 1/2 du. Now, I could put my 1/2 on the inside of the integral side or 1/2 on the outside of the integral side because it's a constant. Which means now I can do my integral, can't I? I have u to the 4th power, then I divide by that 4, don't I? So I have 1/8 u to the 4th power. Now at the end of the day, what am I going to do? I'm going to plug in my 2x plus 7 to the 4th plus c, and that is my integral using u substitution. And if you want to double check, let's take a look at my derivative of 1/8 2x plus 7 to the 4th power plus c. We're going to do the power rule. 4 times 1/8 is 4/8, or 1/2. 2x plus 7 to the 3rd power times the derivative of the inside guy, chain rule, times 2, which is left with 2x plus 7 to the 3rd power, isn't it? Exactly what I started with. So you can see how when you do your u substitution here, sometimes you may have to move a number over to the other side to substitute just for the dx. Now, if it literally said 2 dx, guess what? That 2 dx stands for du, doesn't it? But here all we had was dx, which means to substitute for that, we had to substitute the 1/2 du in for that. Let's take a look at this example. This example, what do we use for our u substitution? Well, I'm going to use my 3x plus 5, okay? Which means I know I'm going to have sine of u. Now remember, anytime I do an integral, my x and my dx, my u and du, it has to match up, doesn't it? Which means I'm going to take the derivative of this, which means we have 3dx, don't we? 3dx. Which means I'm going to solve for dx. dx equals 1/3 du. So my dx is equal to 1/3 du. 1/3 du. Now I'm going to take the integral of sine of u. The integral of sine of u is negative cosine of u. Negative cosine of u, because the derivative of negative cosine of u is sine of u, isn't it? And I get negative 1/3 cosine of u. What is u? Is 3x plus 5 right there, plus c. And that is my integral there. Now, if I take the derivative of negative 1/3 cosine of 3x plus 5 plus c. We know the derivative of sine is cosine. The derivative of cosine is negative sine. So we get 1/3 sine of 3x plus 5 times the power rule times the derivative of that 3x plus 5, which is 3. That makes the 1/3 and the 3 go away, and you're left with sine of 3x plus 5, which is what we started with at the beginning. So you can always double check your answers. That is the cool, the creative, the ingenious integration by U substitution. So I'll see you soon, hopefully. All right, enough puns on you. See you guys. Bye.